Hello, everybody. My name is Shreyans Daga. I'm currently an incoming sophomore at Stanford High School, and for my project, I decided to make a ball tracking robot. For my third and final milestone, I was able to completely finish my project and add my own modification. So, I was this time I was able to connect the H bridge to the Raspberry Pi, and I was also able to write software, which is able to take images from the camera and then figure out the center of the where the center of the ball is, and then once I have that, depending on where the center is, either move right, move forward, move left, or if it's not even in the image, then what to do. And so all of the functions are defined right here. You can see I set up my GPIO pins, I set up my motors, and then I defined all of these turning functions. And this down here is just a little function that you can use for troubleshooting or debugging. Once we had that figured out, I moved on to my modification, which was to add gesture control to this. So the way the gesture control works is that I have an accelerometer right here on a breadboard, and so the accelerometer is capable of detecting acceleration in all six dimensions. So the accelerometer will detect which way it's tilted, and it'll send that information to this Arduino, which it is connected through jumper wires, and then the Arduino will process that information and say that it's tilted this way or this way. And then the Arduino will then send that information to the Raspberry Pi through this Bluetooth module. And once the Raspberry Pi receives that information, it will act accordingly. So, for this milestone, I had to get all of the software for it set up, which I was actually able to do. So, this is all of the software that is responsible for getting the data from the accelerometer and setting up the Bluetooth module and then sending that data over to the Raspberry Pi. And the way that I've implemented the controller or the Bluetooth config file, it'll take whatever command I'm receiving from the Bluetooth module, and then it will act accordingly. So if I receive F as my command, then it'll go forward, and so on and so forth. However, if the Bluetooth module or the accelerometer is staying flat and it doesn't tilt any way, then what we'll do is we'll start automatically looking for a red object and try to track that. And as soon as the human gives me an override command, I'll do that. And so, yeah, overall, this project was a lot of fun. There were quite a few challenges, but we managed to persevere.